is. This first one is a perimeter, a rectangle with a perimeter of 80 to have the largest area. Does that seem
Yeah.
good? All right. So the shape here is you got like X and Y, and the area is X times Y, and that's what we're trying to maximize.
Okay.
The perimeter is, well, all the way around. It's X plus Y plus X plus Y, or more commonly, 2X plus 2Y. But they give you that value. They tell you, oh, that's 80. 80 is the perimeter.
Okay.
You actually did this problem in a pre-calculus class or a college algebra class, but you didn't use calculus. What you do is you end up having this thing you're trying to min or max. In this case, you're trying to max, and you take this equation and you substitute it back in. We're going to solve this equation for y.
Okay.
So to do that, you're going to divide each of these by 2. So you get 40 equals x plus y. Subtract x, so y equals 40 minus x. And then that's what goes into your area equation. This right here comes into y. So it's x times 40 minus x. Your area is 40x minus x squared.
Okay.
So now you have to take a derivative. Derivative is 40 minus 2x, and you set it equal to 0. Now this only has one critical point. You solve for x, you get x equals 20. Because there's only one critical point, you can reasonably justify that this is the only one. And then to find y, you put this value back into the other equation here, one of these other ones, like 40 minus x. So y is equal to 40 minus 20. So y is equal to 20. Now, the shortcut here is that the largest area is always a quarter of the perimeter if there's no other constraints involved.
Okay.
But if you got to show work, that would not be a good thing to do here.
Yeah. Okay.
Okay. So you're going to enter that. We're going to move to the next question.
Yeah, it was right.
All right. Let me just need just a moment here. Okay. Second question is kind of the same thing. It's a rectangular vegetable patch. Is that right?
It says that's number 3, but number 2 is assume that it costs the company approximately.
Okay. All right. Yeah. Let me do that number 2 then first. So.
Okay. Thank you.
All right. How many devices should be manufactured each hour to minimize the average cost? Okay, so the cost here is given, but average cost is different. That's written as the C bar of X, and what it is it's the cost function divided by X. You divide every single one of these terms by X.
Okay.
So it ends up being that your C bar equals 676, 123 plus 160x plus 0.001 x squared, all divided by x. And you end up getting this 676, 123 over x plus 160 plus 0.001 x.
Okay.
Okay, and then you have to take a derivative because it says how many should be manufactured in order to minimize average cost. So whenever you minimize or maximize, you're taking the derivative and setting it equal to 0. So this is C bar of x. So C bar of x prime derivative is, now this is power rule. So this is really x to the minus 1 power.
Mm-hmm.
So it becomes minus 676, 1, 2, 3, x to the minus 2. Derivative of this one is 0 plus 0.001. And you set this equal to 0.
Okay.
Okay, now to solve this, I'm going to move this term to the other side. So it's 0.001 equals, and then this becomes positive 676, 1, 2, 3. And then the x to the minus 2 is down here on the bottom.
Okay.
And then you move this x squared to this side, move the 0.01 over here. So x squared equals 676 divided by 0.001. And then you take the square root of that.
Okay.
I might have mentioned this before. If you can use a tool like Desmos, you can actually get the answers to this by just graphing. But I don't think you're allowed to do that. You're also, if you've got to show work, that doesn't work real well either.
Yeah.
For it. Unfortunately, this is the only way to do this. So I'm just getting my calculator pulled up here, and I'll. The answer is 26,000.
Okay.
And that is it did work out real nicely. So that's 26,000 units. The resulting average cost comes from doing C bar 26,000. So you have to put 26,000 into either of these here.
Okay.
And I'll do that. I'll do that calculation here. So x equals that, and then we got c equals. So we got 676. So I get 212 for that. And then the next question, this has got a lot packed into it. It's probably seen in your exam. How does the average cost compare with the marginal cost? Marginal cost is not the average cost. It's nothing to do with the average cost. Marginal cost, you go back to C of x, and you just find C prime of x. So you don't do that whole dividing by x thing. You just take the derivative of the original function. The derivative of the original function is 160 plus 0.002x, and then you substitute in the 26,000. So C of 26,000 is the 160 plus 0.002 times 26,000.
Okay.
That is also 212. So the difference is 0, and might always be 0.
All right. Okay.
If you're checking these while we go, just always let me know if something is incorrect. That way we can figure it out.
Okay. Yeah. No, they're all correct.
Great. Okay, so question 3, you said is the it's the next picture that I was about to start showing. It's a rectangular vegetable patch. Is that right?
Yeah.
Okay. All right. Okay. I would like to create a rectangular vegetable patch. The fencing for the east and west. So we've got to remember our north, south, east, west. This side is we'll call this X, and this is $4 per square foot. $4 per square foot. Y is going to be up here, and it costs $2 and $2 down here. We want to maximize the area. So area is XY. This is a lot like the previous problem. Now, instead of perimeter, it's cost. So the cost is each side times the value.
Okay.
So it's like 4x plus 2y. So that's these two. Then plus 4x plus 2y.
Okay.
Okay, now the total cost that that person, I shouldn't say he because we don't know who it is 128 equals 8x plus 4y. So again, we're going to solve this for y just like we did in question 1. So you divide everything by 4, and this is 32 equals 2x plus y, and then y equals 32 minus 2x. The area is 32 minus 2x times, well, it's xy times x. So this is all there for xy. So the area is 32x minus 2x squared. The derivative is 32 minus 4x. You set that equal to 0. You always set your derivatives equal to 0 in these optimization problems. X equals 8.
Okay.
Okay, now how do you get y? Well, y we just said is 32 minus 2x. So y is 32 minus 2 times 8. Y is 16. Because we only have one critical point, there's only one answer. Now, if you did this problem on your own and you labeled x up here and y down here, you would get the same answer. You have to make sure that you know, in my case, I said east and west was x. So that's the 8. North and south is y. That's the 16. You have to make sure you do that correct mapping. I probably should have done that first before now. But in an exam, you only get one submission, obviously. So
Yeah.
you just be extra careful there with that. Okay. I see question 5. 4 is you're building a triangular flower garden.
Yeah, with the picture.
Okay. If you ever need a lesson time other than the times that I listed, just message me directly or email me, and I can usually accommodate whatever you want.
Okay.
We got a triangular flower garden, which is weird because I don't know that anyone's ever done this, but they've shown this here. The area of a triangle is 1/2 base times height. They tell you the fencing on the left border, which we're going to call H up here, or we can switch to X and Y, but that's 10. And the lower one here is 2. And no fencing is required along the river. And you want to spend no more than $720 to enclose an area as large as possible. So we're trying to maximize this. We have to figure out the cost. The cost is, well, let's switch to X and Y. So this is 1/2. The base is going to be X. The height is going to be Y. The cost is 10X. I'm sorry, 10Y, because Y goes vertical. 10Y, this is Y up here, plus 2X.
Okay.
And you want to spend no more than 720. So that's 720 equals 10Y plus 2X. And most commonly here, you solve for Y.
Okay.
So when you do it this time, you get some fractions, but that's okay. We'll make that work here. So the Y in this case, Y is equal to 720 minus 2X, and then you divide that by 10. So that reduces to 72 minus 1/5 X. This is what goes into this area equation. I'll rewrite the area equation though down here. Area is 1/2 XY, 1/2 X times 72 minus 1/5 X. So that's 36X minus 1/10 X squared. And just like in all the other problems, you take a derivative. A prime is 36 minus 2 over 10, which is 1/5 X. And then we set that equal to 0. X ends up being 5 times 36, which is 180. Because there's only one critical point, you just assume that one's correct. So X is the bottom border. I need to keep labeling these. Y we get from this equation, or this one over here, both work, as long as we haven't made a mistake in the beginning. So Y is equal to 72 minus 1/5 of 180. 1/5 of 180 is 36. 72 minus 36 is 36. You probably already know this about WebAssign, but sometimes you just check the individual pieces to see if they're correct before going to the last one.
Yeah.
The garden area is 36 times 180, 1/2 of that. Let me get that number. 1/2 times 36 times 180. Is that 32? This number is 3240.
Okay, perfect.
Okay, so now we're up to number 5. Is that right?
Yeah, and that's one that's for tax reasons.
Yes, I see that. Okay, great. There are this is an example of a backwards question. The forwards is you want to maximize the area. The backwards is you want to minimize the cost of the region, because it's the same geometric shape, but depending on the constraints, you can either go one way or the other. So this time they're telling you that the area, which east and west is X, north and south is Y, and maybe that should be backwards, but they're telling you the area XY is 72 this time. That's the big difference. Whereas this was the thing we were taking the derivative of. We're not doing that anymore.
Okay.
The east and west sides cost $4 per square foot, and the north and south sides cost $2 per square foot. So what is our cost equation? It's 4x plus 2y plus 4x plus 2y. It looks a lot like the perimeter cost equation we had before, 8x plus 4y. So we're going to take a derivative of this and set it equal to 0. Well, this is where you have to use this information here and plug it in for y. So you have to solve for y. You often do this always solving for y. So that's 72 over x. So your cost is 8x plus 4 times 72 over x. So cost is 8x plus 288 over x. In all of these problems, you take a derivative, set it equal to 0. The derivative here is 8 minus 288 over x squared. You set your derivative equal to 0. So to solve this by hand, you move this term over to the right. So you have 8 equals 288 over x squared. Cross multiply and divide. X squared equals 288 divided by 8. And then you take a square root of whatever that is. Looks like it comes out to a nice number because they're not telling you to round. If they tell you to round, then that's an indicator that maybe it's a decimal. So in this case, that's 6. But what is x? Well, we called x all the way back up here. We said it was the east and west sides. Just make sure you get that number in the right place. Y, we solve for y. It's 72 over x. 72 over 6 equals 12.
Okay.
So you definitely you definitely want to be able to draw the picture, write the equations, solve for y, substitute in one or the other, and then substitute into the other equation, take a derivative, set it equal to 0. They're all sort of recipe based, where if you do these things, you will eventually get the right answer every time. 6 is Hercules films. Is that right?
Yeah.
Son of Frankenstein. That's weird. Okay. So this time I'm just going to write the equation. These aren't fitting in real well. All right. Okay. They give you the quantity. This is quantity. Quantity is a function of price. And they want to know the revenue. So revenue is price times quantity. So in this problem, it's price times 240,000. Like this. This in parentheses is your Q. They give you your Q, and you substitute it in. They want to know what price will bring the greatest revenue. Well, whenever you're asked to minimize or maximize something, that means derivative. So before you can take the derivative of this, you should definitely multiply it. So it's 240,000 p minus 12,000 p squared. So what I'd like you to just ask you to do is take a derivative, set it equal to 0, and tell me the value that for this one, please.
Okay. Is P equal to 10?
That sounds super reasonable. Why don't you give that a try and see if that works.
Okay. Yeah, that's right.
That's right. Great. Okay. Okay, so is the next one kind of the same, but it asks for the greatest profit?
Yes.
Okay, so I'm gonna do the same thing here. I'm not gonna copy and everything because just the snips are too wide. So they tell you that quantity is 280,000 minus 14,000 p, and they're asking about profit this time. So profit, if we backtrack, profit is revenue minus cost.
Okay.
And we know from the previous problem that revenue is price times quantity. So a lot of letters, but price times 280,000 minus 14,000 p. Okay, that's our revenue. So the revenue is 280,000 p minus 14,000 p squared. The cost, that's something new, but they tell you that each copy costs $4 to make. So C is equal to $4 times P.
Okay.
Wait. Let me just. They do give you. Okay. They switch the variables around in one of these questions upcoming. So profit, and just making sure we don't have profit, is this 280,000 P minus 14,000 P squared minus 4P. So you can take a derivative, set it equal to 0 here. You can combine these first two if you want. You're going to use your calculator anyway, so I'm not sure that that's necessary. But P prime is 280,000 minus 28,000 P minus 4.
Okay.
Whew. So let me see here. I don't feel like this is going to work out very nicely. So it works out to about $10. That doesn't seem right.
Wait,
Let me. I think I might have to restart this question. What price will bring the greatest share? Price times quantity. Did the previous one work?
yeah, it was 10.
Okay. I need to just check something here. Yeah, I guess it is okay. I guess it is p equals 10. Did you try that?
Yeah, and it said it wasn't right.
It was not right.
Yeah, no.
Okay.
Should I try like 9.99?
No, it should have take that. I feel like I'm missing something on this that I'm trying to check here. Yeah. Okay. Okay. Yeah. I messed up here. So I don't know why I did this. I'm sorry. We're going to just backtrack slightly. The profit, the cost is not 4P, it's 4Q.
Okay.
And Q is given as 280,000 minus 14,000 P. So this changes things a bit here. So you've got this, you've got a, let me just rewrite it, 280,000 P minus 14,000 P squared minus 2856. So this is a 120,000 minus 56,000 P. Okay, so now we're going to take a derivative of this. So it's a lot of it's the same. 280,000 minus 28,000 P minus 56,000. And this should give you, yeah, this will give you something that works when you set it equal to 0.
Okay. Is it 8?
Say that again.
8?
It's that's, let me just check here. It's really close to the original number that we just got. Divided by 28. Yes. Try
Okay.
8.
So that's wrong.
Okay. 6,000. Just checking into this. I don't have an answer for you right now. I think let's do this. We got a couple more problems here we can do.
Okay.
And then if we have time, we'll come back to this one.
Okay.
So the next problem here is I see is the postal service one.
Yeah.
Okay. Okay. A postal service will accept packages only if the length plus girth, girth is the perimeter of the front face, which looks a little weird, but it's the perimeter here, is no more than 32 inches. Assuming that the front face is a square, it's a square. What's the largest volume? So we're trying to maximize volume. And if we call this front face X, this X, and this Y, the volume is X times Y, or X squared Y.
Okay.
The girth, or the length plus the girth, the length is Y, the girth is X, 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 4X. That can be up to 132 inches.
Okay.
Do you follow that? I mean, is that okay?
Yeah.
So this is much more like the first few we did. We're going to solve this for Y. Y is 132 minus 4X. This, oops, I went down too far. This goes back in here. Volume is X squared times 132 minus 4X.
Okay.
So the volume we're going to distribute here is 132x squared minus 4x cubed. And this time we're going to take a derivative, or well, not this time, we've been doing that. The derivative here is 264x minus 12x squared. And we're going to set this equal to 0. So we have to factor out some numbers. So 264 is divisible by 12, shockingly. It's 22 minus x equals 0. So there's two critical points this time. There's one at x equals 0, that comes from here. And then there's one at x equals 22, that comes from here. Well, the one at 0 is ridiculous because you wouldn't have a package of size 0. So it must be this one.
Okay.
Okay, and that, I mean, there is more to do than this, but this is enough for the class you're taking and what you're trying to accomplish. So they want the volume. Well, the volume is x squared y. So your volume is 22 squared. And then y you get from this number over here, 132 minus 4 times 22.
Okay.
So I get 21296.
Yeah.
And hopefully that works.
That was right.
Did you see that worked?
Yeah. Sorry.
Great. Glad to hear we're back on track here. Question 9, is it the number of cell phone subscribers? Okay. I'm just looking this over before I snip it in to see. Average annual. Okay. This question here is asking, it's asking you to find when the revenue peaked. That means it's a maximum. So they're asking for they're saying this function right here. when does this function reach a maximum? So if you were to graph this, which I kind of was leaning towards having you graph this, if you graph it, it'll I don't know what it'll do. It'll probably do something like that, and we just find that point there.
Okay.
And that's like part A is the X value and part B is the Y value here. Kind of interesting. We can also just take a derivative. Now, to take a derivative of this, we need to do a little cleanup on it because it's not ideal. Even though the numbers are reasonable here, we do need to do a little bit of manipulations here. So if I multiply this in, I get 13,650t, 350 times 39. But then you also need to multiply by this e to the minus 0.2t. And then if I multiply 350 times 73, that's 25,550 e to the minus 0.2t. Is that okay so far?
Yeah.
All right, now the derivative here is product rule for this first one, because there's two functions here. There's keep the first, derivative of the second, plus the second, derivative of the first. This one's just an exponential one over here. So the derivative here is keep the first, derivative of the second. So we have 13650t. The derivative of this is minus 0.2 e to the minus 0.2t plus derivative of the first 13650 e to the minus 0.2t. For the second term here, you're going to take the derivative in the same way you did here, but it's just got this part to consider. So it's ends up being negative 0.2 times 25,550 e to the minus 0.2t. And you set that equal to 0. So that could be what's kind of hard here. Is like, how do I set this equal to 0? So they all have this e to the minus 0.02t, so you factor that out. E to the minus 0.2t, and then 13,650t times the minus 0.2. We want to get that number, 13,650 times 0.2. So that's negative 2730 plus this number here, 13, there's a t there, 13,650. And then we have this it's kind of the same thing here, this last one, minus 0.2 times 25550. That's a minus 5110 equals 0. So this first part is never 0. It's never t, that's never 0, but this is. So we're just solving this inside thing. We're setting this equal to 0. And we get 13,650 minus 5110, all of that divided by 2730. And it ends up being a number that's not submit your answer in terms of t. That's weird. I don't know why it would do that. The t is oh, so t is described in the question. T is so the answer here I got is t equals 3.1.
Yeah.
Sometimes what I do here is I practice another, I put 1 and 1 in the answers, and then I click on see answers to see if that's even what they're asking for.
Yeah, it looks like the first answer was 3.3 for practice another, so I tried. Yeah, it was 3.1.
So 3.1 is great. And then determine the revenue at that time. So you want to use your unrounded answer, not the 3.1, but you want to put that back into this original. I would just go up to this original one. But you can do that in your calculator with A and S if you need to. But I would I'll do it here for you as well. 350 times. Determine the revenue, round to the nearest 1 million. Okay, so the answer is in millions of dollars, which means you're going to round to the nearest ones place. So 36508 is what I got here.
Okay.
Let me know if that worked.
Okay, it was right.
Okay. Okay. Number 10. Is that that's where we're going? Okay. Okay, 2 years ago, your orange orchard contained 90 trees, and the yield per tree was 85 bags of oranges. Last year, you removed 10 trees, so that means that there were 80, and the yield per tree increased to 90. Assume that yield per tree depends linearly on the number of trees in the orchard. So that's like saying this is X, this is Y, this is X, this is Y.
Okay.
Is that so now what we're trying to do is we're trying to maximize your total yield. The just trying to recenter myself on these problems. So the total yield. Okay. So the total yield. Okay, this is confusing because I have a problem that I write like this, but I just do it with price times quantity. Here the total yield is trees times bags per tree. So essentially your total yield is X times Y.
Okay.
Okay, and it's a complicated way of saying that, but that is what it is here. So you what you have to do is come up with an equation for Y, and Y you can come up with an equation for Y using these 2 points. You can find your slope is y2 minus y1 x2 minus x1. So we can go 90 minus 85 over 80 minus 90. So that's 5 over minus 10. So that's minus 1/2. And then we can write our equation in point slope form. Y minus y1 equals slope x minus x1, y minus, and I'll choose these points here. 90 equals minus 1/2 x minus 80. And then we can solve this for y. So y equals minus 1/2 x plus 40, I'm just distributing this in, plus 90. So y equals minus 1/2 x plus 130. And our yield equation is x times minus 1/2 x plus 130. So we can distribute negative 1/2 x squared plus 130x. I'm going to use capital Y here, and then I'm going to take a derivative of this. So that's minus x plus 130. Set that equal to 0, and x equals 130. And because it's the only critical point, we know that that's the correct one.
Okay.
If there were more than one, we'd have to do some thinking, or we'd have to make some other concessions potentially for that. Hopefully that's clear.
I put in 130.
Yes.
Okay, it says it's wrong.
Okay.
It says you should plant.
So it may be that they want the Y value, which is 65 in this case.
No.
Okay. Give me a moment here to
Oh, I got it.
Okay.
I did 130 minus 80 to see how many more trees to plant, and it was 50.
Okay. Great. So this is a good place for us to stop here. I know we didn't get to every question, but
That's fine.
you'll probably be okay anyway. So thanks again for scheduling, and I'll send the notes and the screen recording out shortly.
Okay, thank you.
You're welcome. Bye now.
Bye.